Good afternoon, children. Today I will discuss about some more compounds where the sharing of electrons takes place. I have told you in my previous class about the formation of covalent bonds, about the sharing of electrons by various atoms to form molecules like hydrogen, chlorine, oxygen. In the case of hydrogen, there was a sharing of a single electron and there was the formation of single covalent bond taking place. In the case of oxygen, there was a sharing of two electrons and there was the formation of double bond taking place in the case of oxygen. I have given you example of water and then I have given you example of carbon tetrachloride. Today I will discuss about the triple bond and about the sharing of electrons. How does this sharing take place? If I take the example of nitrogen, the atomic number of nitrogen is 7. That means each nitrogen will be having 5 electrons in that of a outermost shell. Out of these 5 electrons, the 3 electrons that will be shared mutually to form triple bond. And there will be formation of triple bond and one pair of electron with each nitrogen that will remain unshared, and the one pair of electron that will remain unshared. So in this manner there will be the formation of single bond, double bond and triple bond in the case of covalent compounds, but there will be no sharing of 4 electrons taking place, as if the 4 electrons will be shared, the molecule will become unstable, and due to this unstable molecule it will not be possible to share 4 electrons. There are two types of compounds which are formed by the carbon, that is having single bond, having double bond or having triple bond. Now, it is not necessary that all the compound which containing nitrogen will always form triple bond. Let me take example of ammonia. The formula for ammonia is NH3. The nitrogen will be having total number of 5 electrons in the outermost shell, as its atomic number is 7 and the configuration is 2,5. There will be sharing of 3 electrons with that of a 3 hydrogen, and there will be formation of 3 covalent bonds taking place, and that will be 3 single bond which will be taking place. So these were the examples where the formation of covalent bond takes place. Now, if we compare the covalent compound with that of a ionic compound, I have already told you about the properties of covalent compounds. The covalent compounds are having lower force of attraction. The covalent compounds are having low melting and boiling point. The covalent compounds these are not soluble in water, rather than they are soluble in those only compounds which do not carry any charges, like these are soluble in that of a benzene, carbon disulfide, etc. The solubility is not like that of a ionic compound. The ionic compounds are soluble in those compounds where there is a presence of charges, but covalent compounds are not soluble in those compounds where there is a presence of charges. So these are insoluble in water. The fourth property is that of electrical conductivity. Graphite is an exception. Otherwise, covalent compound do not conduct electricity. Graphite is an exception. Otherwise, covalent compound do not conduct electricity. Now, let me discuss about the allotropes of carbon. There are total number of 3 allotropes of carbon, but before telling about the allotropes, we should know what is the meaning of allotrope and what is the meaning of allotropy. If a compound exists in more than one form, it is having same chemical formula, same chemical properties, but different physical properties. Such type of compounds are known by the name of allotropes. There are 3 allotropes which are very much common. One is diamond, the second is graphite, the third one is fullerene. There are more allotropic forms of carbon also, but that is a different type of forms that is not included in your syllabus. So I will not discuss all those forms. I will discuss 3 forms. The formula of diamond is C, the formula of graphite is C, the formula of fullerene is C. But if we compare their structures, if we compare their properties, structures, these are different from each other. I will discuss first the structure of diamond, then I will discuss structure of graphite, then I will discuss structure of fullerene. If I discuss the structure of diamond, formula is C. Diamond is tetrahedral in shape. What is the meaning of tetrahedral? That one carbon is bonded to that of 4 carbons, and each electron of each carbon is involved in bonding, and each electron of each carbon is involved in bonding. This makes diamond hardest substance. This makes diamond hardest substance. The bond angle is 109 degree 28 minutes. It is tetrahedral. Each carbon is having 4 electrons in the outermost shell. Each carbon is having 4 electrons and each electron is involved in bonding. Diamond is a transparent substance. It is a hardest substance because it do not carry any charges, so it is a non-conductor of electricity. It can be prepared in nature by the extensive temperature, but that process I will not discuss. Now, the second one is that of a graphite. The graphite is having different structure. It is having hexagonal graphite. It is having hexagonal structure. Let me make structure first, then I will tell you. The structure of graphite is in the form of layers. These are hexagonal structure. These are hexagonal rings which carry alternate double and single bond. You will study about benzene later on. So these consist of rings which are alternate. This structure is not hardest structure. Out of total 4 electrons, the 3 electrons are involved in bonding and the 4th electron is at the backward side. These layers can slip over each other. They are attached with each other by weak van der Waals forces. Weak van der Waals forces. These are attached with each other by weak van der Waals forces. These contain double bonds. These contain single bonds. There is a presence of alternate single and double bond. These layers can slip over each other. The forces are very much weaker. These layers are having attached with each other by weak forces, and this is a soft structure. And because there is a presence of one electron at the back side, that is why it is able to conduct electricity. Graphite is used for making electrodes. It can conduct electricity. Now, if I compare the properties of diamond with that of a graphite, so in this comparison, diamond is a non-conductor of electricity. Graphite is a conductor of electricity. Diamond is the hardest known substance, where graphite is not harder. It is a soft substance. Besides that, diamond is transparent, whereas graphite is grayish in color. If we see now, the chemically diamond is extremely hard, unreactive, whereas graphite is reactive. And both of them are having formula C. But in spite of having formula C, their properties are different from each other. So, now you have understood the difference between diamond and graphite. Now, there is a third allotrope of carbon which is known by that of a fullerene. It consists of large number of hexagonal and pentagonal rings. There is a presence of carbon contain 60 hexagonal and pentagonal rings to 150 hexagonal or pentagonal ring, but the most stable is the carbon 60. The most stable is the carbon 60. There are 12 pentagonal rings and there are rest hexagonal rings. It is having shape just like that of a saucer ball. It is having hexagonal rings. It is having pentagonal rings. There is a presence of alternate single and double bond. It is being prepared. It is having a dome-like shape. It is being prepared by the scientist. Only Buckminster geocidic. It is like a geocidic dome. So that is why it is known by the name of only fullerene, by the name of that particular scientist. It is having a shape just like that of a buckyball. Now, this is dome shaped allotrope now, and beside that it is having 6 membered rings and it is having 5 membered rings. It can be prepared, but that method of preparation is not in your syllabus. But one more important thing which I want to tell, that diamond is 3-dimensional structure, whereas graphite is a 2-dimensional structure. Diamond is a 3-dimensional structure, whereas graphite is a 2-dimensional structure. Now, I will discuss one more thing, that is a last topic which I am discussing today. That is the versatile nature of carbon. I will discuss versatile, very important, versatile nature of carbon. Although carbon is present in earth crust only in 0.02% and in nature 0.03%. But beside this, this carbon is having million of compounds. Why it is having million of compounds? Because of its versatile nature. It is having a unique ability to combine with that of a other carbon atoms to make a long chain. There is a one very important unique tendency of carbon to combine with other carbon to form a long chain that may be straight, that may be in the form of ring, and this property, the first property which make carbon versatile, that is known by the name of catenation. Catenation is the property of carbon to combine with other carbons to make a different type of structure. It can make straight chains like this. It can make branch chains like this. These are branch chain. It can make 3-membered ring. It can make 4-membered ring. It can make 5-membered ring. It can make 6-membered ring. And it can make the chains which contain 1200 or more than 1200 carbons. It can make the chains which contain, you have seen that in the case of polythene, this carbon is having 1200 carbon which has been combined in the form of a chain. Now, the first property of carbon is catenation, that it can combine with the carbon of its own type. But it is not necessary that it combines with carbon only. It can combine with oxygen, it can combine with nitrogen, it can combine with sulfur. I can give the example: carbon dioxide, carbon disulfide, then cyanide. There are so many examples which can be given. So it can make large number of compounds. The second most important property of carbon which make it versatile, that is only its tetravalency. Carbon has a valency of 4. It can combine with other elements by making double bond, by making triple bond जो है, it is capable of bonding 4 other atoms of carbon with it. Carbon has a tendency to have it is having tetravalency, it is having capacity to bond 4 carbon atoms with it. It is having tendency to make bond with hydrogen oxygen, with sulfur, and with so many other elements, chlorine, carbon tetrachloride. Then there is a next property that it can form multiple bonds. Multiple bonds. It can form single bond, it can form double bond, it can form triple bond. So all these properties, they make carbon versatile. We are having million of compounds of carbon which are available in nature. Million of compounds of carbon which are being used in the form of medicine, clothes, soap, plastic, so many other things which we are using daily. You go through this chapter from the NCERT thoroughly. If there is any problem, let me know so that could be discussed. It is a very small chapter. Most of the portion is deleted. So if there is any problem, let me know so that I could discuss that problem.